So hello YouTube, day 16. Let's go. Safari. Oh, look at this also. Corporate sponsors, monetary we now have a monetary donations section with big ass logos. With wet ass logos. Anyway, okay, day 16. Nice. So, as you're walking to yet another connecting flight, you realize that one of the legs of your rerouted trip coming up is on a high-speed train. However, the train ticket you were given is in a language you don't understand. You should probably figure out what it says before you get to the train station after the next flight. Okay. Unfortunately, you can't actually read the words on the ticket. Like, this is a funny story. So I have to say, all these exercises have a funny story. This funny story is actually weirdly, like, it's kind of too real. So there's gonna be like a like, this is a pretext, right, to then implement some wonky algorithmic solution to understand what's going on, while the actual answer is you find somebody to help you. Like, the actual answer is that if you're in this situation, you should ask somebody to please help you. But of course, you are a computer scientist probably, so your first thought is what's the algorithmic solution for this, which is sometimes good, sometimes not so good. In any case, you can, however, read the numbers, so you figure out that the fields these tickets must have and the valid ranges for values in those fields. You collect the rules for ticket fields, the numbers on your ticket, and the numbers on nearby tickets from the same train service via the airport security cameras. How you manage that, no idea, but okay. Together into a single document that you can reference your puzzle input. Okay, so the rules for ticket fields specify a list of fields that must exist somewhere on the ticket and the value ranges of those of values for each field. Holy shit, this is gonna be interesting. So, okay, so we see I'm guessing we are seeing the numbers. We don't know which is which, but we know that one of these things has to be, for example, seat number. And we know that seat, and I'm guessing we also somehow know that, yeah, seat numbers can only be in a specific range. So basically, each ticket is going to gives us a clue, right? Each ticket is going to say, well, this ticket has a number out of range here. So you know that this field cannot be the seat number, but maybe there are other 5 candidates, like a sudoku thing. It is a sudoku thing. Is it not? Well, not precisely, but you get the idea. This reads like a programmer's dream about how to fix common problems in a superhero fashion. Wow, that's really an on-point description of this. Yes. It's a power fantasy. Which makes for, I guess, good narrative. I mean, in this context, maybe not necessarily always in an absolute sense, but yeah, that's a very nice way of putting it. So, the rules for ticket fields specify a list of fields that must exist somewhere on the ticket and the valid ranges. So, for example, a rule like class 13 or 57 means that one of the fields in every ticket is named class and can be any value in the ranges 1 to 3 or 5 to 7 inclusive. Okay. Each ticket is represented by a single line of comma-separated values. These values are numbers on the ticket in the order they appear. So every ticket has the same format. So for example, if this is a ticket, oh, okay, that's not the input, right? Oh yeah, yes, that's the input. Okay, so this is like the representation, and it tells you like 101 is gonna be the top left field every single time. Like here, question marks represent the text that you don't understand. The text can be represented, the ticket can be represented as this list of numbers. Of course, nice use of a semicolon, nice. Of course, the actual train tickets you're looking at are much more complicated. Wow, much more complicated. Oh shit. Right, because it has to be enough things. Holy shit, okay. In any case, you've extracted just the numbers in such a way that for some is always some specific field by blah, blah, blah. Start by determining which tickets are completely invalid. Oh wait, we have invalid tickets too? Because these are tickets that can contain values which aren't valid for any field. Ignore your ticket for now. So for example, suppose you have the following nodes. So class can be 1, 2, 3, 5 to 7. Row is 6, 11 or 33, 44. Between, I mean. Seat, blah, blah, blah. Your ticket is this one. So this ticket here has a 4 in it. Can't be class, can't be row, can't be seat. Okay, so these are completely, because of this, you know that the tickets are invalid. 55, yes, no 55, no 55, no 55. It doesn't matter which position corresponds to which field. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any field. In this example, the values on the first nearby ticket are all valid for at least one field. This is not true for the other ones. Adding all together all the valid values produces your ticket scanning error rate. Oh, okay, so the idea is like, right, because you're scanning these things from security cameras, so sometimes the optical character recognition thing fails, and then you get like botched tickets. Okay, I think the reality of this would be much messier. But anyway, okay, so the ticket scanning error rate is summing the cursed numbers. Okay, so we need to find all the cursed numbers and sum them up together. Consider the validity of nearby tickets you scanned. What is your ticket scanning error rate? Okay, let's go puzzle input. Oh, okay, I thought it would be worse. Oh, departure location, departure station, departure platform, departure track, departure date, departure time. Are these always 2 ranges? Okay, so for each of these you need only 2 ranges. Good to know. Good to know. So we have some parsing to do, I guess. That's a bit annoying, but hey. So tickets.txt, const data is, oh, I lost LSP for some reason. Oh, it's fine. Embed file tickets.txt. Var it equals mem.tokenize. What do we tokenize on? Can we, I think we can, let me think about this. I think we can cheat a little bit. We can definitely cheat a little bit. So let's start by parsing this stuff. We tokenize on colon, dash, space, or no, we can't. But we can tokenize on colon and space, can we? That is indeed so annoying because this is not gonna work as expected. This is painful. This is genuinely painful. Up. So here's how we can massage this a little bit. Let me think about this. Is this good? Oh, but you know what? I think we still need the names though. We need to know what it is. Okay, so here's my trick. So we move the space here so that now by tokenizing on colon and space, we can be more robust. We can tokenize this always in a consistent way. I still space and still unsolved computing problem computer science. Well, I mean, when you're trying to be cheap and use tokenize instead of a proper parser, I guess that's the kind of things you end up doing. So we want to tokenize on colon, spaces, and dashes, and new lines. So colons, commas. Commas are for later. Colon, spaces, commas, dashes, and new lines. And let's hope this proves to be good enough. So so what do? We know that we have 20 rules. So var rules is an array of 20 rule and starts undefined. What is a rule? Const rule is I think a rule is basically has a name and 2 ranges, right? That's basically it. So it has a name, which is a slice, and you can change the delimiter bytes on the fly in the token iterator. Ooh, oh, by the way, hi Specs. I can change the delimiter on the fly. Interesting. I think I can. One, this is actually pretty cool. I didn't know about this. Makes sense. Yeah, I could probably. I mean, I cheated already. I mean, I removed a space here to make this basically always one token, even if I tokenize on space. I think I'll be good afterwards. I just need to do the math properly. Should be fine. So, by the way, did you check our new sponsor? I added the logo on the ZSF page on our website. Pretty interesting what they do. So we have a name and we have 2 ranges. Should we make it an array, like range A, range B should be? I think ranges should be an array of 2. Of 2 what? What is a range? We do max min, I guess. Could be, you know what? It could be just an array of 2 Susies, and that's it. Without having to make types. Haven't you check it out? Yeah, check it out. It's interesting. A quick look looks like they do the same thing. PyPaper was supposed to. Yeah, pretty much, I guess. in the initial part, which is, well, I don't know. Were they supposed to be doing fingerprinting in the beginning? I remember that they ended up doing, it became like compression at one point in time. It's been so long since I watched it. But I think the problem is that, like, the reality of it is that fingerprinting it's lossy. It's meant to be lossy. So I forget what the story of Silicon Valley was. Okay, so we have 20 rules. 4 rules. We get a pointer to each rule because we want to set it. So how do we set each rule? First token is the name. So it's it.next.question mark. We have the name. Then I'm tokenizing also on the dash. So we're gonna have the first number and then the second number. So const name. Oh, you know what? I don't even need to save this like in a constant temporarily. I can just do r.name is that. Then for r.ranges, and I want a pointer to each range. Should I do this? Why am I doing this with another 4 and creating this range stuff? It's annoying. I can just do r.range is 0, 0, like 0, 0, 1, 1, 1, 0, 1, 0, right? And each is basically a token. Let me double check. I need to parse them also. Wow, I forgot. But yeah, the idea is this is the first token, this is the second token, this is the third token. Oh, then we have an OR though. So we need to burn a token in between. So it's try, std, fmt, parse int, Susie, the buffer and the base. Okay, so this is the final invocation basically. Okay, and that should be it. We do it for each rule. Then we have our own ticket, which is going to be 20 numbers, and each of these should be 20 numbers. So let's assume that's the case. Let's hope so also. So for rules, then we need to skip 2 tokens for burning your ticket. So rules is this, then var my ticket is a 20 Susies, and this should be a column. And after that, there's going to be also just the other tickets, which are 245. 245, oops, 20 Susies. And this should be like tickets. Okay. So we burn this, we burn that, then we read our ticket. So for my ticket, want a slot to each, a pointer to each thing, and for each we basically do this. We read the number. Then we need to burn, I think, another 2 tokens. Yes, tokens, nearby tickets. Are turning a specific input, do you feel dirty? Not at all. I mean, what can you do? And this is for tickets. For tickets, we want to get a pointer to the ticket, and for t, does it need to be dot star? No, you can iterate a pointer, right? So yeah, you get an n, and this should be it. Also, I'm missing something. What am I missing? I'm missing an assignment. N equals n dot star equals, actually. So for each array, so the array for each ticket, each slot, and then we assign each slot to this thing. And that should be it, I guess. If it.next is different than null, unreachable. Or you know what? Let's do a proper panic. In case we, for some reason, we need to do release fast. Set phase. Okay. So we assert all tickets. So we assert that we consumed everything at this point, and then so what do? That was a non-trivial amount of parsing. It turned out to be easy using tokenize in the proper way. I'm so happy that I learned how to do this. But hey, there is a lot. So now we want to exclude all. We want to exclude all tickets that are bad, or actually we want to catch all bad numbers. So how do we catch all bad numbers? We basically need to do for each ticket and for each number inside the ticket, we need to check it against all rules. And let's take a look at the rules here. You know, this is kind of tempting to like just make a bit array that goes from min to max. And then just boom, check the bit array every single time. Like how far do we go? We don't go much far. It's like not even 1,000. Should we do this? I'm so tempted to do this. Oh, but it starts at like something, whatever. Let's do the naive version first, and in case for some reason turns out to be too slow, we switch to something smarter. But and also, you know what I'm gonna do? I'm gonna put this inside a block, so that if in case I need to copy this parsing procedure, I'll be sure to only copy the right part and not forget something. So for each number, we need to check our rules. So for rules, this is annoying because like if we had constructed the bit array, this wouldn't be a for. This would be a straight check. But I mean, we don't have that many rules, so whatever. Let's see how it goes. So for each rule, we basically need to say we need to search until we find a rule that is compatible with this number. So if this number is compatible with any of these rules, we break. So if compatible, and we need to define this compatible stuff, but if it is indeed compatible, then we break. If we get to the end of all rules and this number is not compatible, so if you haven't broke out of this for loop, no compatible rule found, in that case we need to add this number to our pile of bad numbers. And that's it. Okay, so what does being compatible mean? Being compatible means that the number is something, it's in the first range or in the second range. Being in the first range means being greater or equal the bottom part. So we want n to be greater or equal the bottom part, and n is lower or equal the upper part are 0, 1. And the same thing is here, except that we are looking at the first range. Not the clearest way of expressing this, I have to say, honestly. But hey, not that bad either. I mean, I should not have abused like tuples, arrays of length to that much. Maybe I should have used like .min, .max. But whatever, it's not that bad. So if we find it, then we break. So no bad SUSY appends, and then we say at the end, print bad SUSYs. And that's it. So programming errors. There have to be programming errors. Whatever, we'll find them when we find them. So AOC Zig build day 16. Let's go invalid left-hand side to assignment. Interesting. Invalid left-hand side to the assignment. I think I need to put like braces around all this stuff. I mean, it's the same thing. I just added brackets. I wonder why this wasn't parsing correctly, unless I did something wrong. Use an identifier mem. Oh no, the one thing, std.mem. Error, array access of non-array type rule. Oh, because it's r.ranges, right? Everything is r.ranges. Oh, fuck. You know what we can do? RL is a rule, and R is rule.range ranges. So these can stay small. Okay, these are all our bad SUSYs. I mean, not bad if it's correct. That's the right answer. So nice. I mean, couple of things to fix, but like this one, I would this I don't think it's my fault. I think Zig should be able to parse a couple of nested fors. Hey, Matahi, thank you for the follow. Welcome to the stream. But hey, that went well. So, which means that the second part is gonna be super hard. Let's go. Now we will need to match each rule. We'll need to match each field to a proper index. I know this already. Let's go. It's time. You can murder me. It's time. Now that you have identified which tickets contain invalid values, discard those tickets entirely. Yes, I imagine that. And use the remaining valid tickets to determine which field is which. Using the value ranges for each field, determine what order the fields appear in the tickets. The order is consistent between all tickets. If seat is in the third field, it is the third field on every ticket, including your ticket. For example, suppose you have the following nodes, blah, blah, blah. Based on nearby tickets, you can conclude that in your ticket, class is 12, row is 11, and seat is 13. Once you work out which field is which, look for the 6 fields on your ticket and that start with the word departure. What do you get if you multiply those 6 values together? I knew it. I mean, makes sense. We should not have expected anything different, but so part 1, part 2, return part 2. So, well, I kinda need this actually. I kinda need this. Hello, how you doing? Oh, yeah, you're late to the party a little bit, but no worries, you didn't miss much. So I'm just done with part 1. Did you do it today already? So I'm done with part 1. It went actually super well. Yeah, you're on time for suffering. God damn it. Yeah, or not. Maybe not this time. Maybe we'll get it first try, also the second part. Probably not. So, we kind of want this whole thing to happen. We don't care about the final sum of how many bad Susies are there. But we kind of want to... say, well, we found a number that breaks the rule. We sum the bad Susies. You know what? Okay, that's it. I'm copying everything over. I could I clearly could refactor and use stuff, but hey, whatever. So instead of doing bad Susies, we don't do bad Susies anymore. We haven't found a compatible rule, which means that this ticket is busted. So we want to break. We don't want to break anymore just out of this inner for loop. We want to break out of the ticket loop, because we want to say this ticket is busted. So we break ticket, and what do we do if we break from ticket? Nothing. But if we don't break from ticket, it means that we couldn't find a, let's say all numbers seem to match. Well, all numbers match a rule. So in this case, if we never broke out of ticket here, of this second layer loop, like the middle layer loop, I guess, in that case, we want to mark this ticket as good. So what we need now is like good tickets. So, well, let's do okay tickets. So we have okay tickets, and what we want to do is var I Susie equals 0. And we want to say okay tickets at position I is gonna be T. So we are copying over the entire ticket. We're incrementing I. And at this point, actually, let's call it okay tickets. Good tickets buff, because it's clearly going to be a subset of this, right? So at the end, what we do is just say const okay tickets equals it's a buffer. It's the buffer from 0 until I, and there we go. So now we have basically used this buffer just to... That's nice. Copy over this stuff. This needs a semicolon. Okay, so now that we have our okay tickets, what do we do with our okay tickets? Now the fun begins. Now we need to search stuff. So I think for each position, we need to have a set of potential candidate rules. And every time we find a number in a given position that is incompatible with that rule, we remove that rule, I guess. That's the idea. And in theory, at the end of the algorithm, each set should remain with just one possible thing, if we did everything correctly. At which point, we just use this information to map, to stitch things together. I think that has to be it. So with our tickets, now we need to have this set of potential thingies. I'm gonna call it sudoku because that's what you do with sudoku. I don't know. Nah, that's a bad idea. Because I'm gonna get confused and then people are gonna make fun of me because I made light of this problem and I say, oh, let's call it sudoku, and then I get lost. So no, let's be a good less of a cringe streamer, since already we have Andrew doing that. Let's have this called potential matches. Potential matches is an array of 20 sets. It's an array of 20 sets. I don't understand what a cringe streamer is. You need to be careful, Matt, because if you yourself stream and you don't know what a cringe streamer is, you might find out that you were the cringe streamer all along. So be careful. I'm joking. Actually, you probably have not to worry about this stuff. Of all people, you have, I think, 0% chance of being a cringe streamer ever. So you're good. As I was saying, let's make a type for this particular set. I think I kind of want a type. Do I though? I mean, it's just a auto hash map. std auto array hash map. Keys are SUSIs, and values are voids. Then so I have this array, and then for potential matches, so I take a pointer for each potential match, and in there, so I need to initialize this stuff, right? I have to initialize each one of these things, and then I also have to add to the auto array hash map all 20 possibilities already, and then I'm gonna take them out as I find incompatible stuff. So we need the arena locator too. Put it at the top. No, let's put it in between here. So I have the arena locator, and then I do, each of these is auto array hash map. So I init with the allocator, and then I need to do, can I have the LSP now, please? Enable language server globally. Why did we lose ZLS? I don't get it. Did we really? Like, what happened? Preferences, package settings, LSP settings. Dude. Okay, let's do this. LSP restart servers. Did it work? Oh, I did it in the wrong tab, but maybe it did work. Here. M dot. Please, M dot. Oh God. Okay, let's try to restart Sublime. I just want to see if there's something easy to put stuff in here, like all in one go. Thank you. Entry, result image, clear and free. No, clone contains get or put. No. Put assume capacity, no clone. I guess it's just put in a loop. Okay, no, I was hoping for something better, but no. So for, no, it's not really a for, it's a while I is lower, while I is lower than 20, I plus equals 1, all we do is try to put I, there is no value, so we pass a void value, which is an empty block, and we put all 20 things in there. We need I now. Okay, so now we initialize all the potential matches sets. And now we need to scan every single ticket. And I think we need to scan every single ticket, including ours. You know what? I really think we need to do this. So I think we need to scan every single ticket, including ours. So redefining I in a for loop, does that matter? Good point. I think this shadowing is not allowed. You know what? Let's try to compile just to see what it says. I think it's not allowed though. I think you're right. I think it will complain. Yep, rediculation of variable I. You know how we can fix this? Like here, I don't need this I after this thing. So what I can do, which is actually not a bad idea, is I close everything in a block. And now that I is not shadowing anymore, and we have another problem that OK tickets doesn't exist. Oh yes, because I changed this to good tickets buff. So here's what I'm gonna do. I'm gonna start writing down the good tickets starting from 1, and in position 0, I'm gonna put my ticket. Because I think that my ticket has to also be used to determine, to exclude possibilities. I'm not 100% sure, but it would be reasonable for that to be the case. And this trick of like sneaking my ticket in, I decided here to put it at the beginning. I could also have put it at the end, honestly. This trick of sneaking in my ticket is basically useful so that now I don't have to special case it when doing the search. Oh, they say that on the problem. I might have skipped that part. Oh yes, including your ticket. Thank you. Nice. So I guess now for all the OK tickets, for each OK ticket, we have a search, which I think it's actually not that different from this. Maybe let's not fall in temptation. Let's rethink things from scratch. Let's not copy paste. That has been disastrous in the past. So and let's also use more explicit names so that we don't end up having problems. Although actually, let's just keep this n since we're gonna use it in a bunch of things. Okay, so we have all the rules. We are checking each ticket, each number in each ticket for the rules. When we check the number, now I think we also need the index of that number, because it's necessary to find which rule we need to apply. So wait. Okay. Oof. We get this number in that index. So what we need to do is, do we consult all rules No, we only consult the rules that this slot is this index, this slot is a candidate for. So we say for I think we need an iterator we can do for. So var it, like the iterator is potential matches in the corresponding slot, and while it.next, while we have a candidate, for each candidate we check if the candidate rule is actually valid or not. So we say const r, so these are going to be our ranges, are going to be rules slot candidate dot rules, and then we do the same check. I think I'm allowed to copy here. But if the idea is, if in this case the idea is, if we are trying to check all the rules, and if this is correct, you know what? We don't do anything. I know we should be flipping, I guess, the equation, but guess who's gonna introduce bugs if he tries to do that? This guy here. So all we want to do is, if the rule matches, then that's fine. But if the rule doesn't match, and we need to scan all of them. Yes, we can. We are not gonna break anymore. Now we are gonna do like the full job. Try like this. Oh no! I mean, I'm not repeating myself. I'm just not flipping this thing around. I mean, you know, it used to be a time where I remember all the. What was the guy's name? DeLorean, where the flipping rules, right? Ends become ors, not ors, something like this. Whatever. Too long ago. Too many potential bugs. Curly braces and else branches are my friend. And actually, you know what? I think the compiler at the end of the day is going to optimize this stuff. Okay, so if we are out of range for this rule, we need to remove it. We need to remove that candidate. So we need to do yeah, that's very, very nice nesting. Well, the good news is that this while is going to become shorter and shorter. So here's the interesting question. Can we pop stuff out of our set? Or do we need also to reassign the iterator? Are we going to bust the iterator by popping from the set? So this is one thing that I need. We need to do some due diligence on and go find out what the standard library says. So try hash map. Get or put capacity, put no clubber, put some capacity fetch, blah, 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 contains items. Oh. Items. Wait, does it not even have an iterator? It does have an iterator. Yes, it does have an iterator. You know, I think that the iterator also this items thing is nice. You know why? I think that this items thing is something that the array hash map has. that the other hash map implementations don't have, maybe, of that. Whatever. Okay, you know what? Let's keep doing the iterator stuff. The only problem is we're going to reassign the iterator. Like if we delete stuff, we need to reassign the iterator just to make sure that we don't do weird things like because we are modifying the memory underneath. So here's what we're gonna do. Var made changes is false, but if we get in here, made changes is true, delete. And here, if made changes, we reinitialize the iterator. So delete means just doing, I think, potential matches dot remove. Yes, dot remove what? Candidate. So this should be it, I think. Do we need anything else from here? I think in theory at this point, give me a second. So we should be good, right? We keep deleting stuff. Blah, 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 blah. We make sure that we don't make anything weird with the iterator. Or you know what the alternative could be? We could every single time like make a new set and replace it with the old one. Whatever. You know, that might have been a better choice performance-wise. Something to think about if for some reason this is too slow. Okay, and in theory, once we get here, we are done with the rules. So let's just print the potential matches for now and exit. So for potential matches, for each potential match, we want the match and the index, and we print the index. Oh god, we need a nested for loop. Okay, so we print this, and that's just the I part of it. And then for var it equals m dot iterator, yeah, pretty much. Oh, there's one thing that I think I'm doing wrong, because I'm assuming there's a programming error in here somewhere, and it's here because this is candidate. It should not be next. It's like not next. We only have next. We don't have like next key, next entry, and then const candidate is entry dot key, I believe. ZLS, come on, some support here. I think it's entry dot key. And here it's an dot key. new line, and we should be good to go. Well, let's find all the programming errors. The programming error adventure starts now. Let's see, redeclaration of variable IT. Really? Is there an IT that survives out here? Oh yeah, this guy survives. This guy shouldn't survive. This guy can go in here, which is actually nicer. You know what? Let me do it also here. User identify undeclared identifier I. Oh shit. Oh, this is interesting. This is interesting. So by putting this I inside here, I can't create this array anymore. Which means that we need to do this. We need to do OK tickets. Is the result of executing this block, and we basically break out of the block with this expression here, which assigns to OK tickets, and this is equivalent to what we were doing before. And now this needs a semicolon. So now we solve this too. Then init extracted one argument and found two. That is indeed a good point, because this is dot star equals this dot init. No member name rules instruct rule. What? Oh, ranges. Next, expression value is ignored. Expression value is ignored, but it's not an error, so I guess it gives us the value that we remove. Okay, this has not done what we were hoping it would do. Almost there, I think. Not quite though. We haven't popped anything. That's weird. Okay, we need to fix this. In any case, little blocks are like cheats. Yeah, great cheats, but they feel like cheats somehow. I think they're the future. They're so nice. The only thing that I would like more is to be able to do this. You do like equals colon or something of this sort, and at that point you can break on OK tickets. Well, the idea is that you don't have to come up with an intermediate label that has no meaning, and you can just use the variable name, which is maybe more comfortable. Honestly, I'm not even sure. It's an idea that is floating in my mind. It has, I guess, its own set of downsides too. But anyway, what's up? Why are we never deleting stuff? Why are we never deleting stuff? I mean, okay, this is probably useless to add right now, because if we are not deleting, I just want to make sure that I don't have like a copy of this thing that I'm forgetting about, and that's why it's not happening. But I think it's probably because we are not, yeah, we are never entering into this branch. So we are never getting inside here. Why are we never getting inside here? We need to see if we are considering entry.key. This is not useful enough to debug, but at least I want to see if we got in there. Okay, so we do get in here. We are considering 0, blah, 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 blah. Okay, so now I think we can add a proper debug print. Let me just double check my equation here, because if we're getting in here in a way that seems reasonable, I mean, we're just iterating like up, like in these 4 lines, we're just iterating going down. So this seems ultra tame. So this seems fine, which means that here I'm also just extracting values. And this makes me think that then the, like, you know, the curved line kind of seems to be this. Let's double check. So if n, which is the ticket number, yes, is greater than the bottom range of the first range, the bottom end of the first range, and lower than the upper part of the first range, or so if it's in the first range or it's in the second range, then nothing. But if it's not, then made changes becomes true and we delete stuff. Okay, so this is truly interesting. So let's add something, some useful printing. Ticket number something ticket number something number value something considering rule something. Yes, considering rule candidate. And actually save. Yeah, actually, you know what, we can do it, we can put it here. Mismatch something something. Okay, so we should be able to actually now print debug lines that are pretty useful. So ticket, we want the, I guess the ticket index, maybe the ticket number. Do we want that? Does it matter? Honestly, it doesn't matter which ticket it is. So now that I think about it, because we don't have a mapping to the original file anyway, so should be fine. So okay, value, the value is n. For n, we are considering rule candidate, and then if we made changes, it means that there is a mismatch. So this should tell us how things are going. And yeah, it always says mismatch false. Also, why are we considering so few values? How many tickets end up being okay tickets? Why are there so few okay tickets? Okay tickets len 1. What? 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 I think I programmed this wrongly then. So this I was doing the right thing. Like down here I was doing the right thing. Like part 1 was okay. So it means that I'm doing something wrong in here and I'm excluding tickets that should actually be okay. So let's focus. For each ticket, we check all numbers. For each number, we check all rules. If we found a rule that this number matches, oh no, we cannot break tickets. We need to break rules. Okay. I think I understand what I was doing. I tried to short circuit this too much. So when we find a rule that this number matches, we stop searching for in the rules. So this number is okay. And oh god. Okay. So we're searching through all the rules. If we find a rule that this number matches, we stop searching rules. But what if no rule, bad ticket? So okay, so instead of breaking here, I need to break here and say, okay, we went through the rules. This number doesn't match anything. This is a bad ticket. So it's in here that we need to break from ticket. It's in here that we break from ticket. And by breaking from ticket, we avoid adding the ticket to a set of good tickets. If we do find a rule here, wait, if we don't find a rule here, we break from here. If we do find a rule here, we break from rules. We do another loop here. What if we are at the last number? We don't break. We go in the else branch. Okay, so this should be good now. So now this should have like more than one ticket. Okay. Okay, so we have... Okay. We have more tickets, but this has deleted some rules. Not enough though. What the hell? So we know, oh god, here's what it is. We know that 12 can only be 8, which means that we can delete 8 from any other one, which means that 6 can only be 10, which means can we only delete 6, and look at this. So this simplifies this, which simplifies this, which simplifies this, which simplifies this, and hopefully we cascade all the way to the end. It's really a sudoku. So how many times do we need to do this resimplification though? We know? We don't really know, and we have to pray. Well, actually, we know that it should be more than 20 times. I mean, it's 20 numbers. If after iterating 20 times, we still have leftovers, then there's something wrong. So let's hope. So before printing potential matches, time to, well, sudoku time. So in sudoku time, what do? We say var I Suzy equals 0 while I is lower than 20, I plus equals 1 every round. What do? Search a set with only one element, remove it from every other set. No, remove it from every set. Yes. And we should also say save it as a match and then remove it from every other set. From every set. Okay, that seems fine. So var it equals, well, no, it's for potential matches. So for each potential match, and at the end, here's also what we do. We want var final matches equals is an array of, actually, you know what? It's an array of 20 Susies, but we initialize it to a bad value that we know it's not nice. And we have 20 of those. So that we know that if we see a value that is still a 99999, we know there's something wrong there. If I were to do undefined hoof, I wouldn't be able to know. So these are final matches. So for potential matches, we keep searching. We save it as a match. Well, no. If m dot count contains, if m dot count is 1, we know we have found our match. So what do? We save it. So we do final matches slot index is m dot. Do we have pop? Get entry, get index, get or put value, items init, put some capacity, remove unmanaged. Is there no like a get one of any? Get, but you need to provide a key. Get entry, get index. Interesting. Get or put has some capacity. You know what? We could do like just items 0 dot key, and this should be good enough, I guess. So we save it as a match. And actually, let's like const match is this. We save it, and then again we iterate again all potential matches, but this time we want to modify them, all of them. We don't want them to be const. So I don't know if I really need a pointer in this case. I think I do though. I don't know, let's do We don't care about the index in this case. All we want to do is underscore equals dot. Oh god, do we need to do this for ZLS? Yes. Clear and free. Clear retain capacity. Interesting. Just want to remove match. And this should be underscore. Okay, so we delete everything. Okay, so we save it as a match. We remove from all sets. And if we did find everything this round, we need to break to the while loop. We need to break, but not out of this for loop. Actually, no, it's fine. We can break out of this for loop. It's fine too. We break out of this. We go. And it wouldn't have been a break. It would have been a continue if it was the while loop. It wouldn't have been a break. But we can break out of this for loop because we need to start the search again. It's not efficient. Like this can clearly be improved. But hey, good enough, I guess. So we start again and. And if we don't find anything, so here's the thing though, if we don't find anything, it means that we are done if we don't find anything. So what if we really don't find anything? If we don't find anything, we are basically done. So we can say break outer. It's not really necessary. I mean, we could continue like looping around a few more useless times, but whatever. It is a match. Remove it from every set. Okay, in theory, then at this point, we hope that potential matches, we want potential matches to be empty, and then we want also to print final matches. Oh, so here we can say new line, final matches, new line, don't print anything. For final matches, we do this, I, comma, M, and we're done. You can even delete this. Okay. Well, let's see how this goes. Programming errors? No programming errors. Oof. No programming errors. Everything was simplified correctly. This is, oh god, I should not have copied stuff by dragging. But now we depleted all sets, which seems nice. These are final matches. And now we can finally implement the final equation, which means is we need to find all rules that start with the word departure, and if they start with the word departure, then we need to multiply all those 6 values together. So let's do it the right way. I could hard code all the multiplication numbers, but whatever. So what I want to do is var result is a SUSY. Starts at 1 this time because 1 is our sponge. No, it's not a sponge. It's the neutral element of multiplication. So we start with 1, and then on top of this one we multiplicate for final matches. For final matches, match index. So for each final match, if the rule corresponding to this match, and the rule is the value, So if rules slot m dot name, if std mem dot starts with u8's haystack is rules name, and what the needle is departure. We need a meme namespace. Great idea. Yeah, maybe we do. Thank you. So if it starts with departure, then we want to do result times what? We need to find in our ticket the ith value. So in my ticket, the ith value, and finally you can say result equals result. Woof. Thank you. Today, we actually solved the end-to-end of code without almost any cringe. Not bad. It wasn't super trivial. It wasn't super hard either, I would say. It didn't stress any of the things that I'm kinda like hazy about. So it only asked me to do stuff that I kinda understood well how to do. Everything came together basically first try, programming errors aside. Like once it compiled, almost was already okay. I made a mistake here. I was lazy and I short-circuited this process a bit too much. I went from breaking here, I tried to immediately break out of ticket. Instead, I needed to break out of this for loop, have an intermediate break here for when this search is exhausted without any match, and then this needed to bounce me outside of this break, outside of this for loop, to avoid this like success exhaustion. Like this is a failure exhaustion, this is a success exhaustion. This is, I couldn't find any rule to match this number with, so this is a bad ticket. While this is, I didn't find any rule that I didn't find any rule that any of the numbers could break, so this is a good ticket. I think that this, without else branches and breaking out of labels, would have been way more messy. Maybe I'm wrong. Maybe by being forced of keeping track of these flags manually, I could have gotten it right first try and it would have been too convoluted. I'm not sure. But like this double nest search with reverse things, I don't know. For now, I think that the else branch was really nice. This is non-trivial, and I don't think it's the else branch semantics that are making it too complicated. They are obfuscating a little bit what it means to be in the else branch, although I did add a comment that explains what the else branch means in this case. So I don't think it's the most, how can I say, explicit way of writing down what's going on. But I don't think it's that bad either. And I think this was probably the most convoluted part. Then this part here where we needed to do sudoku, so I kind of was understanding that we were about to do some sudoku thing. I did not immediately understand that we needed to do a pruning at the end. So when I got here, I needed to take a look at the input a little bit more before realizing that yes, we needed to prune all things. So basically we needed to like have the constraint that there can only be one match. We needed to make that constraint flow through the result space that we got. But I mean, it wasn't super secret. Just looking at the input, you immediately notice it. So everything went well, I think. So yeah, congratulations, you crushed it. Filtering in the loose could get messy if you don't tackle it correctly. I see. Yeah, thank you. I think that also doing this 20 thing, like knowing that this is not gonna happen more than 20 times, helps in avoiding the situation where maybe you do something wrong, it keeps looping forever, and you start questioning whether for some reason this is actually what's going on or something like this. I don't know. But like this type of stuff is I'm fairly comfortable with. So yeah, that was nice. I think it just happened to be stuff that I know well. I'm sure that the last one, like with bit shifts and stuff, was probably trivial for people that are used to write algorithms where you need to bit shift stuff around. So yeah, that was nice. Thank you everyone for being here. Thank you as usual for the support. Flandre, Codmonk, Matt, thank you very much. I think we can call it a day. How long did it take? I did take a while, right? I think it took an hour and a half, more or less, in total. So, I guess I'm gonna cut the recording here for YouTube. So bye bye YouTube. See you tomorrow for the next video.